Jackie, and welcome to my Physics 2212 Lab 2 presentation. So Lab 2 was basically a continuation of Lab 1. And in Lab 1, the procedure was to create two positively charged pieces of tape and suspend one piece of tape, the top tape, and bring the second piece of tape very, very close under the top tape to create a repulsion. And with the distance of that repulsion, we were able to calculate the charge of the piece of tape, which was 1.1 times 10 to the negative ninth coulombs. And in lab 1, we calculated the charge of the tape as a single point charge, but in this lab we will be calculating the charge of the tape as a distributed charge. And the concepts used in this lab are Coulomb's law and distributed forces. In experiment 1, we found the length of the tape to be 19.6 centimeters, the mass of the tape to be 1.6 times 10 to the negative 6 kilograms, and the floating distance between the two tapes being 2.2 centimeters. And after calculating, we found that the gravitational force and the electric force were both 1.92276 times 10 to the negative fifth. And in lab 2, the gravitational force stayed the same. However, the electrical force changed by almost double the amount of lab 1. The model on the right represents how we calculated the magnitude of electrical force for lab 2. So the red balls represent the top tape and the blue balls represent the bottom tape. And the green arrows are there to show the forces of the bottom tape were acting upon each section of the top tape. And so the green arrows are the electric forces of each section acting on the upper section, and the yellow arrow is the total of all of the green arrows' forces, and the purple arrow is the magnitude of gravitational force. And so the n value is equal to the number of sections that we split the tapes into. And so we also found that the precision increases as n value increases because the density of charge equals the charge divided by n. And the code for the program is on the next slide and in the description. The most important of this part of this code is lines 30 to 36, which is the calculation of the net electric field or net electrical force. And some assumptions we had to make for this lab was the electric force was distributed uniformly along each section of the tape. And for lab 1, we had to assume that the tapes could be identified as point charges with all the charge at the center of the tape. And in order to calculate the electric charge for lab 2, we had to assume that the electrical charge from lab 1 was correct. And we also had to ignore air resistance, and we had to assume that both the tapes had the same charge. And additional questions we had is, what if you had modeled each of your tapes as a single point charge like in the previous lab? Compare the estimated value of the charge you get when you use your experimental data to produce a point charge model to the value you got with the line charge model. And so the point charge model yielded us a result of 1.92276 times 10 to the negative fifth newtons, and the line charge or distributed charge model gave us 3.53727 times 10 to the negative fifth newtons. The distributed charge was almost 2 times greater than the point charge model. And so why do these estimates differ? Which value is more likely to be closer to the real value, and why? So we explained that they differed because they differ in which the distributed charge is almost double of the point charge, and which value is most likely closer to the real value? Well, the distributed charge model takes multiple smaller charges and adds them up to a total charge, which also explains the first part as to why it may be greater than the point charge. But since we were able to take each individual component rather than one central component, we were able to find a more realistic approach to finding the charge of the tape. So therefore, the distributed charge for the distributed charge model would be more accurate than the point charge model. Thank you.